super excited that you could join us today, both in person and online. This is the third time we are hosting a grand seminar. It's an event organized and hosted by, two teams here within Microsoft ADC. That's Microsoft AI for Good Lab and the Microsoft Research Africa Nairobi. The whole session is divided in like two big sessions. So we'll have the first session, which is going to be three invited talks. And then the second part will have a panel discussion, diving deeper into our theme of today, which is AI for Africa's future. How we can use AI, how can AI really help us drive innovation, equity, and impact here in our continent, Africa. So at this point, please allow me to welcome Dr. Jacki O'Neill, the founding lab director, Microsoft Research Africa. So Dr. Jacki leads a multidisciplinary team focused on building technologies that improve working lives and support sustainable futures. At Microsoft Research Africa, she's driving research towards globally equitable generative AI, developing culturally and linguistically aware tools grounded in the African context. At this point, everybody, let's welcome Dr. Jacki O'Neill to give us a
Thanks, Millicent. Hi, everyone. I do have some slides that I just made this lunchtime. So since I went to the effort of making them, I feel we should all be able to see them. So no, while Millicent's putting the slides up for me, I'm really delighted to be here welcoming both people online and people in the room, especially those who came out in the gloomy rain today to make it to Nairobi. So I'm going to talk mainly about equity. I could also have talked about innovation and impact, but I only have 10 minutes and we have a really, really good array of speakers and panelists, and I'm really looking forward to hearing them speak. So I will be a bit less social scientist than usual and not waffle on too much, I hope. So without further ado, I want to cover why we need equitable AI research. As I'm sure everybody in this room and in this virtual room knows, generative AI models that currently exist today do not work equally well for all communities and businesses. And then we've got a lot of research from across Microsoft Research which has illustrated this. And I'm just going to talk through a couple of examples right now. So first of all, if we think about language, there's around 7,000 languages spoken in the world, but most models are only trained on about 100 of them. And English, despite being spoken by less than 20% of the population in the world, actually makes up here on this slide for this common crawl data set, which is a Reuters content. It's almost 50% of the web content. I've seen other stats saying that 2/3 of web pages are in English. And of course, this matters because the vast majority of the training data for generative AI models comes from the web. And even the supported languages have poorer performance than English. So even your European languages have poorer performance than English. And as you go down in the content and the amount of resources for the training data, performance really goes down. So we know that AI has a language problem. But what about culture? Again, training data for LLMs is web-based. So communities that aren't on the web or are underrepresented from the web are also underrepresented in the way that information is produced and represented. And in addition, the data on the web isn't representative in how it actually portrays different communities. So these models that exacerbate inequities, misalignment, stereotypes. And in the next couple of examples, I'm gonna go through some research which shows this. So, for example, we conducted some research here looking at small businesses using generative AI in Nigeria and Kenya. And they reported that AI is really Americanized. And they all had problems when doing work involving African contexts. So when they're doing your generic thing of writing, wanting to write an email to tell someone they're a bit late with the bill, but to sound really polite, it works pretty well. As soon as they're doing content which is more African facing, it tended to break down. So a couple of examples of this. Oh, we looked at image generation, voice generation, text generation, search, and so on. So for example, voice cloning gave this CEO a British accent, which takes away from her originality. She's not British, she's Kenyan. Or this hiking guide who was trying to generate a picture of a black man sliding in a hike and found that the results were unusable. He was slipping on snow, and they were not climbing Mount Kenya. And apparently the background did not reflect like the African background either. And research in India as well has shown there's a significant variation. There's this really nice paper called DOSA, where they looked at different artifacts from different subcultures in India, and then they tested a load of different models to see which models could recognize those artifacts, and there was quite a lot of variation between them. And in addition, many groups and communities across the world are also excluded from the AI revolution. So generative AI models fail to produce images that appropriately represent people with disabilities. Sometimes it's just poor representation and a bit weird. Sometimes it's outright offensive. And generative AI tools tend to reproduce normative identities and narratives and rarely represent less common arrangements and perspectives. So, yes, AI has a language problem, but even more importantly, and often overlooked, is that AI has a knowledge problem. And currently, whole continents and their knowledge are severely underrepresented, and this comes through clearly in use. And it means as well, it's not just that people are badly represented and can't generate the types of content they want. It also means they can't get the same value from these models. If you think about these small businesses who are early adopters of the generative AI tools and really enthusiastic about using them in their work, they're not getting the same value as a small business in North America, for example. And so this just exacerbates the digital divide. So we need to think about how we can tackle this inequity. And one of the most exciting things about this time is that we're at the very beginning of this transformation, and things are moving fast actually as well. And we have a rare opportunity to influence the technologies that will shape our world in their infancy. Decisions made now will influence what work and society look like in the future. And it's not often that you can be at that moment when technology is coming out and iterating and it hasn't fully formed, and you can influence what it's going to end up looking like. So if we can find methods and techniques of building more equitable models, more inclusive models, and the tools on top of those models, we can create a better future for everyone. And so it's really worth reflecting on this question: what kind of future do we want? And so at MSR Africa, we have an ambitious research agenda to build globally generative AI. So we conducted 2 years ago, 1 year ago, can't remember now. 2 years ago, we conducted a really big workshop. We got thought leaders from across the continent to come together and think about AI and the future work in Africa. So we had business leaders, we had researchers, we had AI leaders, we had youth voices, and we produced a white paper with sections led by different people. It was in collaboration with the African Union and the Oxford University as well. But as well as thinking about how models are used and what we want our future to be, we also need to think about how we can actually innovate and build more equitable AI models and tools. And this requires us to do human-centered AI. So it's not enough to have models built just by machine learning people. Machine learning people are essential to building models, but on their own, they're not enough. We need to bring in lots of different disciplines, lots of different perspectives, and really think about how we can design AI that works for the communities that we're building for. And so the way we do that here, this isn't the only way, there's various ways you can do it, is that we ground our research in real use cases. So we have a couple of projects at the moment. We've got one on health stories where we're collaborating with a partner from Stellenbosch University Public Health Department. And it's about trying to use large models to generate stories for people living with type 2 diabetes on how they can change their health and behavior. And that's pushing these stories at image and text. And they're going to also be audio, and one day we hope video. And they're going to be, we're currently in English, but then English, Afrikaans, and Xhosa. But I'm massacring Xhosa, sorry. I can't do the click. And we're really trying to understand how can we get large models to produce culturally appropriate content. We also have another project with Jacki from Digital Green, where we're really pushing the boundaries of small language models, because we have to think about how we do resource-constrained AI. It's really expensive to train AI anyway, but it's really expensive to run AI. And if we want to have AI infused through products and services that are going to serve more people, we need to find more cost-effective ways of doing that. So with that project, we're looking at small language models, building a model, speech model in Kikuyu. And we're also helping Digital Green unlock, they have a large video library. And can we help farmers, if there's an answer to their question in the video library, can we return that snippet of video? And so we look at these use cases, and then because of them, we do machine learning innovations. And we're also thinking about how do we create new research methods which fuse different disciplines for innovation in data ecosystems, evaluation and benchmarking, model innovation, and resource-constrained computing. And these things are deeply interlinked. And the more work we do, the more we realize that these are not separate categories. It's not like you can just do data and not think about how you train and optimize your model. So the main research areas, and this is my last slide, that I just want to leave you with thinking about are some of the things we need to think about if we want to build equitable AI is how can we build AI technologies that produce culturally and linguistically appropriate content for different communities, regions, demographics, and languages? How can we center multimodal and multilingual knowledge and interaction? Text isn't the main means of interaction for large swathes of the population. How can we center diverse user groups and populations in model design? And one of the things I think we would love to end up at is enabling different groups and populations to take models and adapt them for themselves without needing to know any machine learning. That's quite a challenge and a little way off. And How do we build new evaluation paradigms? What are the new evaluation paradigms which better understand model performance in complex real-world settings? So those are the research questions that I'm just going to leave you pondering as you listen to the rest of these amazing speakers today in this exciting session. Thank you.
Thank you very much, Jackie, for such a thoughtful, energizing, and thank you very much for your inspiring opening remarks. Guys, can we please appreciate Jackie one more time? And yeah, thank you for your leadership in the equitable AI space, Jackie. We appreciate your efforts. At this point, we'll have our first speaker, Dr. John Wamburu. I'll just bring back the slides enough for you. Yeah, so we'll have our first speaker, Dr. John Wamburu, a research engineer at Google. His work focuses on applying AI and machine learning to focus global food insecurity, work that sits at the intersection of innovation and social impact. He holds a PhD from the University of Massachusetts, and is the recipient of the 2024 ASIG Energy and Doctoral Dissertation Award. So today, he'll be speaking about, driving innovation through collaboration, harnessing the power of AI to drive social impact. Everybody, let's welcome Dr. John Wamburu. So we'll take 1 second to share his screen.
All right. Can you hear me? Okay. So as you just heard, my name is John Wamburu. And before I get started, I just wanted to make sure that I'm clear on why I'm sharing my screen and we're not using the screen that was here before. We had a small banter because they wanted me to use their stuff. But we're going to use Google Sheets because Google Sheets are better, right? All right. So as you heard, I'm going to speak to you about Google Research Africa. I'm a research engineer there, and I've been working in the ecosystem for a while. I've worked with some of you in the audience today, came from IBM, and now at Google. So today we'll talk about Google Research Africa, the type of work that we're doing and the impact that we're having. And, just echoing and building on what Jackie has said, thinking about this from an African perspective and building solutions that leverage AI to help our continent and also scale globally. And let's get started. So this is Google Research Africa. And as you can see on the map, there are two conspicuous yellow dots. They represent the two offices we have so far. We have one in Nairobi and we have one in Accra, Ghana. And the image on the left there is a beautiful office in Ghana. And the reason we exist is
there was a group that came here.
All right. The reason we exist is to try and build a world-class research organization based here in Africa, and it's going to build sustainable solutions for our continent and also scale these solutions globally. So at Google Research, our main focus is to find the most pressing problems for our continent and then build AI solutions that solve these problems. And one amazing thing about doing things that way is when you build solutions in environments of scarcity and areas where there isn't a lot of data, it's very easy to scale this to other regions where data already exists. So Google Research works under what we call the iDream ethos, or impact-driven research and moonshots. We have a number of projects in the lab. They span a whole lot of different areas, and I'll go over each of them really quickly. And then for the rest of the talk, we'll pick one and we'll do a deep dive into it. So the first line of work we have is on forecasting and mitigating floods. As you know, floods can and are a big problem for a lot of people in the world. So just not very long ago, there were flood events in South America, sometimes in Europe, and we have a group in Google Research that's working on predicting and helping organizations that react to such incidences with data to give them lead time to, for example, evacuate people and so on and so forth. Next up, we have an effort that focuses on mapping buildings. This is what we'll spend our time mostly on today, so I'll not say much about this now. We also have work that is concerned with predicting weather from satellite imagery. This is an especially interesting problem for Google Research Africa to be working on, because part of the reason why we don't have as accurate weather forecasts as other areas in the world is because this continent lacks a coverage of high-tech, radar systems that record the weather at very fine granularity. And one of the efforts that we are leading is to augment this with, imagery data, use machine learning models to predict weather. And the results are quite outstanding, actually. And we just launched this work across about more than 40 countries in Africa. And the screenshot on the right, it's showing outputs from the type of weather predictions we're doing with AI on Google search already for a lot of users in Africa. This is very new. It just got announced, but it shows how the work that we are doing is already having a real impact on the ground. We also have work that aims to reduce traffic emissions by optimizing traffic stops. We also have work that is geared towards improving maternal ultrasounds. And this is work with, I think this was work that was done with Jacaranda Health. And I saw someone from Jacaranda Health earlier here. We have another exciting effort around forecasting and optimizing food security operations. So if you didn't know already, more than 2 billion people in the world face some sort of food insecurity. And when we talk about food insecurity, what we mean is you don't know where your next meal is going to come from. So this is a problem of high magnitude, and one of the teams that we have in the office is focused on forecasting where such insecurity is going to happen, and then help organizations such as the World Food Program to optimize intervention measures. So really exciting work there. We also have work that is concerned with detecting wildfires. And lastly, this intertwines very closely with what Jacki was speaking about. We have an effort that is trying to improve voice recognition for African languages. This paints a very broad picture of the type of work that we are doing at Google Research Africa. What I'm going to do now is I'm gonna pick one, which is mapping buildings. We'll go into why this is a problem, why we are focusing on it. We'll show some of the approaches that we are using to solve this problem. And then I'll show the impact that this type of work is already having on the ground. And with that, let's get started. So buildings, why should we care about mapping buildings? And it turns out that buildings are essential for a number of reasons. One, they're used by governments for urban planning. So doing things such as electrification and, building connecting roads and so on and so forth. Knowing where buildings are is quite important for these types of work. Buildings are also very important for population estimates. So in places like Somalia or DRC, where there hasn't been a regular census for a long time, upwards of 30 years actually, knowing where buildings are can help organizations estimate the number of people who live in an area. And moving on, buildings are important for humanitarian response. So if an organization such as WFP or the UN is trying to plan an intervention somewhere, having a layout of the buildings that are there, the type of people to expect is very important for this type of role. This is also important for recent events such as vaccine distribution, and we just went through this not too long ago. So the main takeaway here is it's important to map buildings and know where they are. And the reason we are focusing on this is because this is a key problem for the global South, not just Africa. And one of the main reasons or the main drivers why we decided to focus on this problem is Google Maps has a low representation or coverage of buildings. What you're looking at on the left here is a part of Cape Town in South Africa, and on the right, this is the representation of this area on Google Maps. As you can see, a lot of this is very approximate. So, Google Maps did not have a very clear representation of where all the buildings are, and this shows why it's important for us to start looking at this types of problem. And it's not that Google Maps is underserved in this regard. Most governmental organizations don't even know about these buildings. And this is a problem for planning and for emergency response and so on and so forth. Another reason why this is a hard problem and why there isn't a lot of coverage of buildings in the global South is the global South and Africa in particular has a lot of very diverse buildings. So we have cities, entire cities built on water. If you don't recognize this left photo here, this is somewhere in Nigeria. We have a lot of buildings that have grass roof structures, and this makes it hard to, for example, differentiate between a building and things like haystacks. We have areas and regions, this is probably somewhere in the north, where buildings look very similar to the ground itself. And we also have very, very close buildings. So this could be like in the slums, like in Kibera, and so on and so forth. This makes it challenging for us to map buildings in the global South. And we need new and innovative ways of moving from this type of imagery to having buildings represented on maps. So how can we go about mapping all these buildings that have these diverse characteristics and move from a map representation that looks like this on the left and move to what we are seeing on the right, where we have an idea of where all the buildings are, how big they are, and that type of information. So one way of doing this, and we are very lucky to be living in such times, is there exists very high resolution satellite imagery where by looking at this area, we can start to build polygons of where buildings are, and this can enable us to move from what we have on the left to what we have on the right. And this is what this project mostly focuses on. So to do this, how we use satellite.
No, we are still cleaning them. So the blank ones, we'll still clean them, but for now, it's good that the student know that.
Okay. So how we did this is we used a data set of about 100,000 high resolution satellite images. And these are super high res images of about 30 to 50 centimeters on ground resolution. And these are images that were selected to be as diverse and representative as possible, coming from different environments, touching buildings, many buildings, small buildings, sparse regions. And we had a lot of examples from each of these different areas so that we could increase the representation in the model and make sure that we're not missing any area. And like I said, the focus was on the global south, so most developing nations. And if we were to be able to do it here, then we can do it anywhere. And these are the types of buildings that are very typical in the developing world. Next, we used human annotators to label where all the buildings were in most of this 100K images. So this gives us a very good training and test set for us to build our models, fine tune them, and make sure that we can capture what the human annotators were seeing on the satellite images. So on the right here, you can see a sample image. It's very high res, and this type of imagery is mostly used to, for example, identify roads, do things even as small as identify manholes. So this was a good starting point for us to start labeling buildings. Next up, once we moved from the satellite imagery, we used a semantic segmentation model to draw and segment where all of the buildings were. So for each pixel in the image, we decide whether it's a building or not. And once we have this, what we have in the left, we have an idea of where in the whole image, each pixel, whether it's a building or not. And then we use some post-processing to turn these IDs of pixels to polygons. So if we identify that the building is segmented in this way, we use some post-processing to build polygons that place these contours on the ground on a map now. And from this, we get a location of where this polygon is and a representation of how the building is outlined. So this went over like a lot of different model architectures and different tuning techniques. And towards the end, I'll share a link to the paper where you can go and read about all of this different models and how we came to settle on these polygons. In the end, once we have the polygons, we publish them with what we call a plus code. And a plus code is like an artificial address for areas like here that don't have an official addressing system. So each of this building has its own plus code, which can be accessed from Google Maps. And in summary, this is how we move from high-res satellite imagery to having polygons that are representative of buildings on Google Maps, which is very cool. Now, I'm going to share a bit about the dataset itself. The data is open, and it's called the Open Buildings Dataset. For each of these buildings or polygons that we've identified as a building, we share a number of data points which these humanitarian agencies can use to, for example, focus on an area. So each polygon has a lat long of the centroid of the polygon. We share an idea of the area that is covered by the polygon. We also share a confidence about how sure we are that this is most likely a building. As you can see, this moves from about 0.65 to 1. So we are fairly certain that these are buildings. And then we also share the actual geometry of the polygon. And finally, there is a plus code which you can use to pinpoint this location on a map. And this is how it looks on the left. And on the right, these are all the data points that you can use. And this can be used by anyone. It's open, including people in the room. What is the type of impact that we are seeing from this work? So to start with, the Open Buildings dataset contains about 1.8 billion polygons. So these are buildings. And this maps about 60% of all the buildings in Africa. So we're continuing to build this, but this is a significant milestone. And globally, remember what I said before, is we want to build AI solutions that solve our problems, and they also scale globally. And globally, we cover about 40% of all buildings in the world. Now, this data set is already having an impact on the ground. A lot of humanitarian organizations are already using this to plan and optimize their operations. And this data has been instrumental in some key humanitarian response examples. In 2023, the earthquake in Turkey and Syria. These organizations relied on this data to know where people were and the type of impact that had happened on the ground. In Pakistan, the floods happened in 2022. They also relied on this data to, have a sense of the impact that was happening on the ground. And there are countless more of these examples of how organizations are already using this data that was built out of the Africa Lab to optimize their humanitarian responses. And this goes to show the type of impact that we're already having on the ground. Next, after showing the impact, the team also thought about how the general populace and people could easily explore this data. So while it's true that most of the people here can, work with the data points that I just shared, we also built a tool that people can use to explore the data. So you can go and select your own use case, and from the use case, you can see how things are changing on the ground and so on and so forth. So I encourage you to go check it out. The link is here. I didn't put a QR code, but if you search it, you can find it, and I'll share the link towards the end. And this brings me to the most exciting part of this presentation, which is I pulled a small demo from this tool for you to see how this works and how this looks in real life. So remember, I said that this type of data can be used for a whole lot of use cases, and I outlined a few, and we're still seeing others come up as people play with the data. One of the other use cases is the ability to track the evolution of areas over time. Now, we have an example in the tool which you can go play with later, and this is very relevant to the people in the room because I'm sure all of you know about this area. So the region I chose was in, let's see. Oh, it says it cannot play this file for some reason. I don't know what the reason is, but let me make that happen. What? No, I'm gonna make it happen. Let me make this happen. Okay. All right, here we go. So this is a demo from the tool that is showing the ability to track the evolution of built areas over time. The area that I'm showing right now is Kibera, which we are all familiar with. The area to the left here is the area to the area with like very concentrated green and lit area is Kibera, and this is the closeness of buildings. This area towards this side is Langata Road, and the road all the way up there is Ngong Road. And this is showing the evolution of this area from 2016 to 2023. So as most of you know, there was that road that was built right through Kibera that connects Langata to Ngong Road. And you can sort of see it manifest itself in this area here, this region down here. So when we're looking at 2016, it was still very built up. But from like 2017, they started clearing the area. And, you know, towards 2023, you can see how that road just changes the outlook of this region. And if you go there now, there's this big road that's going through all the buildings that were there before. And the reason I chose this example was to show how we can also track other things in built environments. So there's a need, for example, to track reforestation, to track how people move, and so on and so forth. And this type of data is helping us, you know, have similar tracking capability in built environments. And I thought this was really cool to share. And there are a number of other different examples in the tool that you can go see, but this was the most relevant to most of us in the room for sure. Yeah, I did all of that for you. You're very welcome. So if you want to learn more about this this work, where can you go? We already have the paper out. For those of you who want to get into the weeds, you can read the paper. It's already on archive. On Earth Engine, on the Earth Engine catalog, the app is already there where you can see the open buildings dataset and play with the polygons. We also have a dedicated website for the open buildings dataset. This is where you'll find a lot of announcements, things about updates to the data. So for example, we have a latest one and maybe another one will be coming out in the near future. And if you have questions or want to learn more from what other people have been asking, you can find the Google community for open buildings. These are multiple areas where you can find a lot of information and get in the weeds on how to use this data. And that brings me to the end of the presentation. Thank you very much for your time.
Thank you. Thank you very much. Thank you very much, John. Let's appreciate John again. Guys, you have so many questions, including a comment. When you couldn't play your slides, we were like, why don't you try PowerPoint slides, Microsoft PowerPoint? Anyway, so we have our question is, the first question, is from Gideon, and he's asking, what's being explored to get coverage close to like 100% for Africa and the world? Like, is there open source contribution to this report?
Good question. So what's being explored is, first of all, we need to get a lot more satellite imagery to support the expansion of this to other areas. Also get better models. So part of the reason why we don't have 100% coverage, even in some of the areas where we already had imagery, is because we're not confident enough that we can ID these buildings. So this is mostly from a data increase point of view and also a modeling improvement perspective as to whether there is there's the ability to contribute to this from an open source perspective. I don't know. Maybe I'll get back to you on that. Yeah.
Hi, great presentation. My name is Daniel. I'm doing my.
Yes.
Great. My name is Daniel. I'm doing a PhD in information science at Cornell, doing my ethnographic fieldwork here. I recall a few years ago, Facebook had a dataset similar to this.
Okay.
Yes.
They did?
Yes, I think so.
Okay.
So I guess it's really about like open source. And I know this is probably above your pay grade, but I wonder like how we could harmonize both from the larger entities and also some small startups here that are doing similar work. So how can we? Yes.
Yeah, that's a good point. I think I mean, you're right. I probably don't have the answer to this. But doing this openly, similar to what we are doing with large language models now, would be one way to like have a harmonized way of doing this type of work. But for now, this is all Google, and I wasn't actually familiar with this Facebook effort. I'll go look it up. Mm-hmm.
Hi, thank you very much for the presentation. My question is about, because on the catalog also you have the nighttime lights. And so the question is, for your current open buildings data set, are you enriching that data also with the nighttime lights of NASA's Black Marble product, just to enrich it so you know it's residential, not residential, or even maybe perhaps it can help you increase the coverage from maybe 60% to 70%, even though like the resolution is going to be worse.
Yeah.
But yeah, there have been any kind of trials down that path, or were there some lessons you tried down that way and you were kind of like, this won't work? So if you can just share that. Yeah.
Yeah, that's a very good question and very good points raised. I think one of the biggest impediments to this coverage as well is, as I said, in the data availability. One of the things that we're trying, you're right, if we find this imagery here, it will not be as high resolution as we would like for us to do this type of work. So we are trying different models that can, for example, upsample low res imagery, which is widely available, to like very low resolution, which can enable us to do this type of work. This is work that is ongoing. And if we're able to crack that, then we can increase the coverage significantly. But those are good points. And we're already thinking about how to upsample the imagery that's already available here, but may not be as high quality as we would like.
Is there enrichment to it from the nighttime lights or not yet? Like, like residential, non-residential, industrial, and so on and so forth.
No, not that I'm aware of right
Just
now.
the extraction of that.
Yeah, not that I'm aware of right now.
Yeah. Some clarifications. What are the metrics, properties that are being tracked in relation to buildings, count, neighbors?
Good question. And I think one of the most important ones is building heights, which was previously not available in Google Maps at all, but is now rolling out on Google Maps across the world. So we are doing building. This is, by the way, I just said it like that, but this is a significantly hard problem. So building heights, when you have polygons, you can obviously do things like count, and we're not doing roof type in this work, but we have other efforts that are, for example, looking at things on the roofs, whether there's solar installations and so on and so forth, but that's not part of this data set.
How often is the data updated?
Not as often as we'd like, but there are, how many iterations do we have right now, William? Yeah, so I think the last one was maybe late 2023. Yeah. So again, as always, the biggest impediment is the availability of data, but there's a new release coming up soon. I'm not sure when, but there is for sure a new release coming up soon. But the latest one was in 2023, which is where we keep 2024. Yeah. Oh yeah, the release was in 2024, but I think the data was up to 2023. Yeah.
Thanks, John, for that. Nice seeing you again. It's been a while. Follow-up question. Maybe could you speak a bit about the computational experience and cost that you went through doing this? And I'm saying that because you work for Google, and not everyone is privileged to have the computer access and capabilities that you could be having there, maybe someone even at Microsoft. And so for someone trying to do this from, let's say, a resource constraint setting in the spirit of Equitable AI, what are the learnings that maybe you could share that would help in getting some results that are good enough, maybe not as perfect as you'd get with your system, but But yeah, like some pointers, even in terms of maybe some research findings that you've found your way to this.
Very good question. And this is very relevant for us again. And I kept saying we want to do things for this environment that can scale. One of the things I'm going to say is most of the models that were used to generate this data are convolutional models, which, these days, I think you can even do it on CPU systems. It's true, it's hard to get to the level of compute that's available in companies such as Google and OpenAI and not Microsoft and that type of thing. But you can get to a level of getting buildings with simple models. They may not be to this scale or to this accuracy, but with simple models like the ones we have shared in the paper that are just purely convolutional networks, you can get to like a good enough performance, especially if you're focusing on, let's say, just Nairobi or a use case that doesn't cover the whole world. But to get to this level, then you will need a bit more compute. But if you focus on a smaller area, I'm sure we can do a lot with smaller models. And the paper lists all of these different models that we went through one by one, all the way to the end of settling on the current state-of-the-art segmentation model that is being used to detect roads and so on and so forth. But before that, there are also other simpler methods that have been tried. But yeah, thanks for the question, Sam, and you should go read the paper. Right.
Yeah. Thanks a lot, John. By the way, I read the paper a while ago. So at the Microsoft Air for Good Life, we were also working on a similar problem, and I can testify that it's a very hard problem, but very important. And I'm pretty happy to see that work is being done. The dataset that was released by the Google team was a great one because it has that temporal aspect, yearly temporal aspect. Something that someone asked here about how harmonized are the existing data sets. There is one data set on open source, one called Overture, that is combining a lot of open source data sets, including from OpenStreetMap, Microsoft Building Footprint, Google Building Footprint, and that's a great setup. And when it comes to how to be data efficient in, I would say, training such models, it's a good idea to start from whatever is out there and see how you can improve it. And so, yeah, I will just stop there. But yeah, thanks a lot for your presentation. And yeah.
Thank you very much, Jules. Is that it?
Yeah.
Okay.
That's it for questions.
All right.
Thank
you, everyone.
Thank you very much, John, for quite a wonderful presentation and, open sourcing your data set. Irene, our colleague, works a lot with postgraduate students, and one of the concerns we've been hearing a lot is, we don't have data set to, hone our research skills on. So this is great. Yeah.
Well, now they do, right?
Now they do. Irene, you can take that. And yeah, our students from like CTech and Strathmore and all of them, we have data now. Yeah, thank you. At this point, we will have our next speaker is Jacqueline, Dr. Jacqueline Wangombe. Dr. Jacqueline is a data scientist and project manager at Digital Green. She brings a unique blend of expertise across veterinary medicine, agricultural economics, and data science. And she's leading efforts to transform agriculture through AI-powered tools. Her work on Farmer Chat has supported over, 25,000 farmers with climate-smart advisory services and strengthen agri-systems across Kenya. She'll be speaking on from from chart to harvest, how farmer chart, is transforming agriculture with AI. Guys, let's appreciate Jacki. Let's just go on.
Can everyone see my screen? And can everyone hear me? Yeah? Okay. So yeah, I always feel very embarrassed when I'm being introduced. I don't know why. I just feel like I'm being put at the center and I'm like very, very afraid. And it gives me so many jittery feelings, but I'll try my best not to be panicky around you guys. So yeah, as you've heard, I'm Jacki from Digital Green. I am currently the project manager. Basically, what I do is ensure that the products that are created by our product team are rolled out to the farmers. Then we collect the user feedback and give it back to the product and engineering team for them to improve on the products that we are currently rolling out. So a bit about Digital Green. So it is a global development organization that builds AI-powered assistants that help small-scale farmers around the globe to improve on their productivity and incomes. So our mission is to create a world where farmers are able to use both technology and data to build prosperous communities. And we've been around since 2008, where we have been working with extension agents to boost productivity and incomes through cost-effective public extension systems that offer innovation and development tools and technologies that service the farmers. So since then, we've seen a result of tenfold reduction in cost in terms of making sure that these technologies are reaching farmers, as well as about 24% increase in incomes among smallholder farmers. So I'll take you through our journey from where we started from up to where we are and what we hope to be next, because we are not yet done. We are way far off from even being done. So the first thing we started with is identifying what are the challenges that farmers are facing. Our farmers provide the food for us, what you eat, what is on your table, but yet they are faced with a lot of challenges. One of them being relying on the traditional extension system, which in the current setting and in all the countries that we operate in is really under-resourced in terms of finance and human resource. So this results into only 30% of the farmers being reached by the extension workers. And this means that many of them are left out without receiving the support that they require. So as a result of this, we have found that we have quite a high extension agent to farmer ratio. So extension agents are those people who initially were supposed to go from farm to farm, giving advisory, making sure that farmers are receiving services such as, fertilizers, pest and disease control chemicals that can help them improve their productivity. And as of late as last year, we were getting like about one extension agent serving about 1,000 farmers, which is a very tall order if they need to do farm-to-farm visit, which is the best care that the farmer can get. So that has been quite an issue, and this has resulted to farmers having limited access to both the personalized agricultural advisory that they need to have to increase their productivity. So the other thing that the other challenge is language and digital literacy barriers. So most of our farmers, first of all, may lack smartphones. That's a key issue. They lack smartphones. And even those who have smartphones, they don't know how to use them. And this is what I mean. Most of our farmers use smartphones as feature phones, either for calling, texting, taking photos, or M-Pesa services. And if you find those ones that are that we call tech savvy, they're those ones on WhatsApp. So you can identify that there's a huge gap there. And that has been one of our key issues. Like farmers, even when they have smartphones, they're not using them efficiently. Then there's also the climate change. So currently we can see it's raining quite heavily. Well, we are happy. We are happy that it's during the long rain season, but there are times when we're having flooding. When we're expecting rains, it's not raining. So that has been quite a challenge to our farmers because most of them rely on rain-fed agriculture. Then there's also the fragmented agricultural extension system. So as a result of the gap on the from the traditional extension systems, so many players have come into play. So you find input supply companies providing extension services, NGOs going to supporting provision of extension services, and all this, they work in silos. So there's a lot of inefficiencies that are happening, a lot of duplication happening, and this results in inconsistent farmer advisory services. So as a result of these challenges, so our first entry point, we call it the second generation, but it was a first entry point. We thought, how could we utilize technology to make sure that farmers are receiving extension services in a cost-effective manner? So the first thing that we did was to create videos by our local farmers and for the farmers. So basically, this is where we are recording a farmer adopting a certain practice in the farm. And then this is moderated by an expert to ensure that the content that is on that video, it's actually the right content. And then this is again carried by the extension agent and showcased to farmer collective and women self-help groups so that they are able to see what farmers around them are doing, and they're able to adopt the practices. So this worked very well because first of all, it had a lot of trust in it. If you see your neighbor implementing something, I'm sure that you'll be able to trust that it's something that is going to work. So that is, it brought a lot of trust, and because we were also showing it based on the seasonality. So for instance, we would show a video of how to add fertilizer, for example, to the farm when farmers are supposed to be applying fertilizers on their farms. This is to make it very current and very consistent to what they're doing during that particular period of the seasonality. So as a result of that, we were able to produce over 7,000 videos. You heard Jacki talk about us trying to utilize the videos now as much as those that are still current and those that are still usable, making sure that you're using that content. And this created over 8 million views, YouTube views. 97,000 extension agents were trained on how to create these videos and support farmers in creating these videos. And 5.6 farmers, of whom 61% were women, were able to watch these particular videos. As a result, this reduced the cost of adopting a practice per farmer and made it much more easier for the information to reach the farmer. Now, while this was good and worked really well, there were still some things that we couldn't quite record on farm. For instance, we could not record some of the practices that were very specific to the farmer. This could include like site-specific fertilizer recommendation, which only would apply to your own farm based on how your soil is and based on your location. So some of those, we couldn't record them on video. So we thought again, what do we do about that? So the second thing that we did was come up with deterministic bots. So this bot, you would have data. So it had data from two particular angles. So it had data from them. We helped the Ministry of Agriculture have registries of their farmers and registry of their extension agents. So that means it's getting like their contract, their farmer profile, where are they based, where is their geolocation, and as well as getting data from SIAT which is part of CGIR, to give us the site-specific fertilizer recommendation data. So they had already done the mapping, and they could easily tell based on the location, this is the fertilizer you should apply, and this is the amount that you should apply. By using that, we were able, 80% of the farmers adopted at least one new practice. And this showed that there's a 38% increase in yield over using the generic fertilizer recommendations. So this worked really well, but again, it had its own shortfall, because this is it couldn't adapt like the way generative AI adapts. So it was based on already preset data sets and preset rules on what it could give to the farmer. So we thought we could take it a step further. Hence, farmer.chat app. So this is an app that is AI powered. It offers a personalized, on-demand, localized advisory to both extension agents and farmers. So it works on, first of all, when you get into the app, you're able to build your profile, including your contact info, your own personal data, as well as the farm data. What are you farming? What is your location? And this allows the app to give you very, very specific advisory. So this has been quite, we've seen quite a lot with this and a lot of learnings with this. And we've been able to reach women better, low literacy by using, as well as we understand that not every farmer has a smartphone, but we've been able to utilize the social networks. So by going through the collectives and going through like women groups and farmer groups. So that has been quite a game changer. So some of the things that our farmers are currently asking is more on the agronomic information. So like what is the correct spacing, for instance, to plant a particular variety of avocado. And even going ahead and asking like we're in September, what and the coffee is flowering. They are supposed to be doing this during this season. So that is one particular set of questions that farmers are asking about. Then there's also guided processes. So how can I make ginger spray for cabbage pests, for instance? Other questions that are being asked are more for diagnostic solutions. So my mango, for instance, my mango has failed to flower this season. What can I do? So the app is able to give recommendation of some of the chemicals that a farmer can be able to use to control pests and diseases. And then predictive advice. So basically, most of them want to know which crop, first of all, which variety can I plant in order to make the most money. And this has given us quite good feedback. So some of the farmers, so this is an example of a feedback from a female farmer in Kenya. So they said that they always wanted to farm cabbages, but they didn't know where to start. Then farmer chat showed them what to do. So out of this, we've had 43%. This is from a study that was done last year in October. 43 of the respondents rely exclusively on farmer chat for advice. So basically, when they're in season, they're going to farmer chat to ask questions, and that has been quite helpful. So 70% of these respondents found it very effective in solving their agricultural challenges, and at least 30 of them had already or planned to adopt a certain practice. So in another study, it showed that 89% they expressed high satisfaction. That is a rating of 4 to 5. And in terms of being effective and being very accessible. So what next? So as I said, we've just started. We've just we've just scratched a very small surface, and we need to do a lot in order to make sure that we are giving farmers the advisory that they need, the services that they need in order to increase their productivity and income. So as we speak, Farmer Chat has been able to reach over 160,000 farmers in all the regions that we operate. 73% of these users are accessing the service for the first time. So it's quite a new thing. Being able to chat with the phone has been quite interesting, because most of them either ask an extension agent or ask a fellow farmer, but they've never had the opportunity to ask a phone to respond or an app on a phone to respond. Then 20% use voice. This is because, again, as we were talking, the AI is challenged. So when you try to speak to it, our accents, our English, which is not very grammatically correct, does not translate well into text in a way that the AI model can understand. Then 90%, they use the local languages. So this, and for us, right now we are saying local language is Swahili, but as Jackie said, we are currently working on Kikuyu. So out of this, we want to, make sure that our UI is simple. It understands the context, it responds in a natural language, and it anticipates the user's needs. So that is the first thing, having a conversational UI that is really, really catering for the need of the farmer. Again, is making sure that it can be tokenized, meaning that you can add features with ease without necessarily having to construct a new app every time, and branding as well. So that is one of the things that we're going to do. In addition to that, together with Microsoft, we're trying to fine-tune our Kikuyu model for Kenya. We're trying to fine-tune our Kikuyu ASR model. So that is an ongoing piece of work. And Jackie, I think we are testing it next month, we'll be testing it next month to see how that works. And then the other thing is ensuring that we have locally relevant small language models for offline operations. So even as we said, farmers have smartphones. Some of them are very low-end smartphones. They're not like the iPhones that we have that can, process and be used for very, very heavy apps. So some of theirs is where you put in the app and it collapses, then what do you do from there? So trying to have small language models that can work offline and can cater for the low-end smartphones, that would be quite helpful, because especially for those farmers either who stay in places where network is quite poor or cannot even afford the data bundles themselves. So the other thing that we are working on is reducing the cost. Again, this is by using small language models as well as caching some of the common answers to make sure that we're not always in the cloud, and they don't need to go to the cloud, and also reducing reliance on expensive third-party services to make sure that we have farmers, even those with low-end phones and those without internet connectivity, getting advisory. Then the other thing that we want to do is make sure that our latency is reduced by 60%, meaning that if it was taking 5 seconds to respond to a farmer, now it takes like about 2 seconds. The other thing is having that our AI and ML and machine learning models are operating efficiently by ensuring either we measure and compare the different models. How are they working? The large model, how is it working? The small language model, how is it working? Which one gives the best answers and which one runs faster on low-end mobile phones? The other thing is, as Jackie was saying, benchmarking on what works best. Do we use the small language models for, generic pest questions? And do we use the large language model for either pest and disease diagnosis? And how does that work? And making sure that the system can automatically interchange between the two models. Then we rely a lot on agronomic advisories, like what the researches that have been done by researchers. So therefore, we would like to create a high quality and a trusted golden Q&A that can be used by other organizations to actually train their models. And this would foster collaboration, making sure that this is also open source so that they can have access to it. By using them, they can help us make them even better. So this is by relying on the experts, so the agronomic experts, the veterinarians, people involved in livestock and crop sciences, to help us come up with the correct answers for the questions that are commonly asked by farmers, and ensuring that this is now shared publicly for other organizations to use. Then the other thing is having the same experts. Can they get in to help us identify which is the correct answer? And then this is used to train the model to make sure that it continue adapting to giving it very localized localized advisory for the farmer. So, addition to that, one of the biggest challenges with agricultural apps is that they are only active when your farmers are in season. When they go off season, they stop engaging with the app. So what are we trying to do about that? So first of all is trying to come up with ideas of gamification and rewards. So by them uploading their content, by them answering questions, answering trivia questions on the app, can we increase the engagement and then incentivize them for that? So this creates a leaderboard. We count the leaderboard and then give them incentives based on how much points they have. And they also get to be recognized by their community peers. And that brings a lot of recognition within the community. So also by adding an AI crop calendar. So basically is this having the farmer having an assistant telling you that tomorrow you need to apply fertilizer. So you need either to go purchase or order from your cooperative so that you're better prepared tomorrow. So having that gives you guide to guide can be, we think it is going to be one of the game changers, but we had to test it out and see whether it will work. Then the other thing is behavioral nudges. So we personalize, making sure that we understand, and it's as if the app knows who is interacting with it at a particular point. So we've seen that one work, especially because we've been sending out a lot of nudges in-app and WhatsApp nudges, and it has been boosting our engagement so far, but we hope to work on it some more. So the other thing is we all know that we can't continue using generic advisory. We needed to make it very specific to the farmer's need. So by using combining large language models as well as with dynamic models such as specific site fertilizer recommendation, it would make it very, very specific to the farmer. As we saw with the deterministic bot, the learnings from the deterministic bot, that when you give very specific site recommendation, then they're able to implement and they're able to increase their productivity. So that is other things that we're trying to see, combining the language models together with dynamic models like site-specific fertilizer, and making sure that these models can then again be expanded into other value chains. So if you start with maize, can we have adding, like you can add millet, can we add wheat without necessarily having to build from scratch again? So can we just keep on adding and making sure that the model can learn based on also the feedback that the farmer is giving? Then finally, not finally, but almost finally, it's making sure that we are getting a lot of user peer-to-peer content. So this to farmers trust each other. So if they see it, we learned that from our videos. So if you see farmers see each other, like, on videos, seeing each other giving success stories as a result of the advisory they have implemented, this will help increase the engagement and farmers coming back to interact with Farmer Chat. And so usually, after being given advisory on productivity, farmers will always ask us, so what next? So I've increased my production. So what do I do next? So the next thing they'll be like, I need market access. I need input access if it's during the production season. I need financial access in order to get money to buy my produce. So the next thing is to find out, how do we link our farmers to these particular individuals we call the service layer providers, those who provide financial access, provide input access, provide market access. How do we do this and make it also, again, very specific to the farmer? We give you, like, for instance, if you're asking about a fertilizer, can we give you a recommendation or a product catalog of those agrovets that are very, very near you, like maybe 5 kilometers or 3 kilometers near you, and you're able to compare prices and see where can I buy from? Also getting like AI market prices, you get like real-time information on the market prices so that it can help you help the farmer make decisions. So when we were depending on the traditional extension system, we were spending about $35 per adoption per farmer. When we went to the videos, it went to $3.50. Now we are trying to see whether can we get to the 0 to the 35 cents with farmer chat. But this is not possible by ourselves. We need a lot of collaboration. We need a lot of researchers. We need the government to come in and steward some of these products, as well as, create enabling policies for the same. We need the private sector to come in and, provide the services, the finance, the market, and the input access, as well as being the people who bring in the scalability and sustainability angle for the same. We also need the development world in terms of funding, as well as building capacity for our farmers to be able to use such products. And thank you. Hoping that I haven't rushed so much.
Thank you very much, Jacki, for quite an insightful talk. This is, so exciting to see some of the impactful work we are doing here in Kenya and Africa. Yeah, do we have questions for, yes?
Hey, so I just have one question. When you ask a chatbot, for example, to give you advice about growing a crop that is illegal, how does the chatbot tackle that? Are there like ethical guidelines behind that? Yeah, just curious.
That's an interesting question, one that we haven't really explored to see. I'm trying to imagine what type of crop you're talking about, but maybe we should test it out. Maybe get farmer chat and test it out and see what it gives you. But most of the time is when you won't get it, because again, for that particular crop, which I'm assuming I know which crop you're talking about, you rarely find like any agronomic advice for it. So most of the time is when you won't get any feedback on the same. So it only gives feedback when there's research that has been done on how to grow that particular crop you're talking about, which I don't know about, but I'm assuming I know.
Yeah. So, Mark, my question is, my friends and I were developing kind of similar. We've been working on a personal project where we're developing an agri-tech solution. So the question is that more on the conversational AI, I've seen you kind of using a multimodal agent or AI. Is it like custom, or it's making use of the agent? Because the way you've on our end, when we were building that feature, because we've accomplished one task in terms of crop detection, we just built something that is custom as using the CNN. So I wanted to know where possibly you got the data and how I can possibly access the data in creating that project. And whether it's multimodal AI, because I saw you can give it a map, you can give it an image and even a video, that it can analyze that on the chatbot and give you some insights. So I wanted to know, possibly in case you worked on the AI, how the data, where you got the data on something like that, how you can advise here.
Okay, so disclaimer out there. I'm not on the back end. I'm usually on the front end of things, making sure that the product is rolled out. In terms of, I'd say in the different data sets, we utilize data sets that are very open sourced right now. Initially, we started from CalRO data set, what they could give us from their research. But again, we know that research gets to be outdated quite fast. So what we did is that now our language models tend to go search for the more public and open researches that are done by different organizations such as CGIAR, ILRI, all those type of research organizations, and that is what has been used to give back the responses that farmers are getting. The other thing is in terms of getting third party services, such as currently for pest and disease diagnosis, we're using Plantix for that particular feature. So we're using Plantix. For our weather model, we're using another organization called Tomorrow Now. So basically, it's also trying to integrate third parties as well, which we are trying to see how do we collaborate better in order to reduce the cost. So that's the best I can answer that question. Wait.
Yeah, we have some questions in the.
So what we're trying to do, like for the golden Q&As, we're trying to create them fast. So first of all, create them from what farmers are asking mostly, then bring in agronomic and livestock sciences experts to make sure that they give the accurate answers to that. Then that will be publicly open for anyone who wants to use to train models.
Okay, so on farmer charts, can one set the farm location? It looks like the arm sets your location by default.
So the app detects automatically where you are. So what you need to do is that whenever you go to your farm, you need to go back to edit your profile so that it can pick that particular geolocation, and then it updates automatically. So you cannot be able to set it remotely.
Yeah, maybe other neighboring jurisdiction.
We are happy to collaborate. We are happy to engage, and we're happy to talk about it. Yeah.
Please reach out to Jacki. Yeah, and our last question from Kibao.
Thanks, Jacki. Great presentation. Quick one. How is the success rate in the local language you mentioned? I saw Amharic, at least Swahili is mentioned, but more importantly, what didn't work so far? What are the challenges you see so that, yeah, people can.
So I can say that our app can be able to communicate to farmers in Amharic. It's not there yet, but it's something that is working. And we're right now collecting user feedback from our farmers in Ethiopia, just to see how do we continue improving the Amharic language. What is in works is the Kikuyu work here in Kenya. That has it hasn't moved as much as we would like, but we're trying to test out different models and work on them. That is something we are working together with Microsoft to see how best to improve those particular models. So that one is still far off, Kikuyu. It's still very far off. And I know some other languages in India are still very far off. So what needs to happen, for instance, this was a conversation we were having in another forum, that for Kikuyu, for the Kikuyu speakers, we know that we have accents on top of some of our vowel letters. Some things that the model that we're using is not, the models that we have don't clearly identify. So it makes it hard to even translate it to English or translate English to Kikuyu, and that needs to be worked on. So those particular models really need to be worked on to be able to be localized as much as possible.
And Swahili?
Sorry?
In Swahili?
Swahili is working, again, not so well. And here's the reason. While the model is really good for Swahili, it is Kiswahili Sanifu, which is Swahili that we rarely use, because the last time we used it was in high school, right? Not spoken, we don't speak it. And the Swahili we speak has influences of our local language, English. So we are trying to see, again, can we adapt it to that type of Swahili? Otherwise, if we leave it as Swahili Sanifu, it's very challenging for our farmers.
That's what I actually asked the question when you say Kikuyu. I was wondering, I think at the Effort Good Love, is Jill's around? We are trying to work on similar advisory with Farmer Line and as an entity in Ghana. And the Swahili by itself is very challenging. And definitely we can think and see how we can collaborate along with Jacki.
Yes.
But yeah, good to know the progress.
Thank you. Jacki, let's appreciate Jacki, guys, one more time. So ending our first session, the invited talk session, our final speaker is Wycliffe Waweru. Wycliffe is the head of digital health and monitoring at PSI, Global Digital Health Team. With over 20 years of experience in global health, Wycliffe specializes in designing scalable digital solutions that strengthen health systems across both public and private sectors. So at PSI, he leads digital health and data analytics efforts at both global and country levels, using tech and data to tackle health challenges. Today, Wycliffe is going to talk about, from chart to Okay, yeah. This is sorry. Wycliffe is going to talk about generative AI. The future of health behavior change communication. Sorry about that, Wycliffe. And yeah, let me just share Wycliffe's experience. So can we please appreciate?
I was about to do an impromptu presentation on agriculture. Anyway, yes, we are in the health space. What PSI does is, in short, try and get people everywhere to lead healthier lives. And we do that through, primarily in the past through social marketing. For those who are in the room from Kenya, a lot of our condom products, a lot about, our behavior change communication we did in the past through different ways of, through different modalities. And I'll touch on that a little bit. This is the only definition I'll give. Often, I work at the intersection of health and technology, and the tech people and the health people speak different languages, right? So I'll try as much as possible, as I usually do, to spell things out that we all may not be familiar with, but really what social and behavior change communication is trying to do is promote change in a couple of things: your knowledge, your attitudes, your beliefs, and ultimately your behavior. And we all know how difficult that is. It's very easy to pass information along, but the underlying factors that determine how you behave are a lot harder to change. And we've been on a journey for over 50 years trying to influence healthier behaviors of people. And personally, I got into this journey as an undergraduate in university. It was at the height of the HIV pandemic. There's a lot of infections. This was 25 years ago. And at that time, there wasn't as much availability of antiretroviral therapy, the medication you take to reduce a viral load. And, there was a lot of stigma attached to HIV. And so a lot of the work we did then, even as a young undergraduate, we went on radio, a group of us, and myself and a friend were hosting and producing a radio show up in Eldoret that was serving the northern and western parts of Kenya. And it's easy to do a presentation like this because I can get feedback from you, right? Imagine trying to, there's two of you in a little studio of an FM station, of an under-resourced FM station, speaking to hundreds of thousands of people and not really knowing, are they understanding are they getting it? Are we speaking to your needs? And that's a challenge I think that you'll see continuing to flow as a thread. How do we really get to shift the behavior of an individual on matters that are personal to them, right? Not to a generic 24 to 50-year-old man, but to an individual. And that's something is a challenge that we continues to exist and we continue to deal with. And so that was my radio experience. And, we transitioned away from that. One interesting thing was, as we're trying to get feedback, this was in the pre-mobile phone era, right? And so often the only way our audience will reach us would be to drop notes or letters at the studio. And once someone showed up at our hostel wanting to speak to us, and I was like, okay, maybe there's a line there that has been crossed, but it was really difficult getting audience feedback. Over time, I think, I transitioned into PSI, and what PSI has been doing for, especially in the, from the 90s into the mid 2015s, was doing a lot of work on mass media, running a lot of behavior change campaigns on your TV. For the Kenyans in the room, you remember the Wacha Mpango Kando ads, the Tume Chill, a lot of work that shifted behavior in a positive direction. But the challenge with TV and mass media is that it's really expensive, right? And now it's increasingly not reaching the number of people you'd want it to reach because we've all moved away from TV. We're all on our phones. And so the shift towards mobile telephony happened. We began to do a lot of work, with sending messages through SMS, through USSD, and trying to get people through that, structured few characters, few words you could send, trying to get people to address those the factors that determine their behavior. And finally, you know, in the recent past, began to work more with chatbots that were structured, yes, but reaching people through, you know, through WhatsApp or through social media platforms. And the beauty of this is that it enabled us to, while it was structured and had a menu, you really followed what your interest was, right? And again, the continuing thread of we are building for a generic group of people and not really reaching the issues that affect an individual. While that is happening, you know, the other approach we and, you know, everyone who works in the health space does doing behavior change communication is working through community health workers. And, you know, our colleague previously spoke about agriculture extension workers, and it's the same process where people who live in the community walk door to door and meet people in groups, you know, with a job aid that helps communicate. And while that is great, you know, often there are questions around what's the quality of the communication you're providing, and sometimes the job aids are a little outdated. And so what we've been doing in other places, especially in Ethiopia, is working to digitize those job aids. So making it a little bit more interactive, you know, bringing audiovisual components to it. And I think that has been working pretty well. But I think our first foray into the world of AI was in 2022 into 2023. Many of you might have heard of a company called Babylon that built out this symptom checker. What you would do is, well, first, what is the practice? And what's the practice many of us have had in the past is when you're getting symptoms and you don't know what you do, you know, you go to Google search, right? You type in your symptoms, and then it gives you a list of web pages that tell you what you might have. Usually, or many times you'll get, you know, it seems like you have a very serious illness, right? I have a headache and oh my goodness, I think I'm going to die. Or depending on your mix of symptoms, it might even tell you you died yesterday. You know, you're already dead. All hope is lost. But I think the question really was what the Babylon project, the Babylon company was trying to do is, can we help you walk through a list of symptoms and identify potential, let me say differential diagnosis, a list of potential diagnoses you may have, and then get you to figure out, once you know what you might have, signpost you to a health facility that is close to you that can serve you, right? And so we had built what we call a provider locator app that then enables you, based on your location, figure out, okay, for these symptoms, these are the kind of health providers I need. And these are the ones who are around me. If I want to call them, I have their contacts, I can navigate to them. And this worked really well until, unfortunately, Babylon went under, ran out of funding and were unable to sustain their model. But I think the lesson for us there was there's a way in which we can help individuals understand what their health need is, and then be able to get to a health facility to receive the support that they need. Which brings us really to a project we are working on currently, and it's seeking to address the barriers of HIV treatment in South Africa. I told you that 25 years ago I was working in this space, you know, and I think I'm coming around full circle, and the challenges still exist because HIV is still a highly stigmatized disease. A lot of people, even though there's access to testing and access to medication, you know, especially for men, about 25% of the men in South Africa, and I think it's very similar here in Kenya, who test positive are not in treatment, right? And I want to ask a question. Why do we think that is? It's because men are stubborn. Everyone leads with stubborn. Everyone leads with stubborn, right? And I think what we learned, and this project sought to understand why is it first that men are not getting access to that care. And we realized that is a lot of what we think, even as a man, a lot of what we think about men is based on stereotypes and misconceptions, right? And what we found is that what men really fear is loss, right? You're afraid of that, the loss of your health, the loss of your strength, right? HIV is stigmatized. So what happens to my social relationships, right? What happens to my status, to my respect? And so there's a lot of fear that's underlying why men are not able to seek and access healthcare. And you'll notice that there's nothing around, it's a lack of knowledge, right? It's really psychological and mental aspects that are preventing that access to care and treatment. And so what the project did was, come up with a model of a coach. Think of a sports coach, right? And it really was somebody from your community who has walked this journey with a man and who has a story to tell about how they've been able to manage from their diagnosis to treatment and are living very positively with HIV, and would be tethered to men who are testing positive early and walk the first 6 months of the journey with them. And through this model, we're able to see that moving men, men were, while 75% of the general population were not able to, 25% were not able to access treatment. We're able to increase that through this model from 75% accessing treatment to about 95%. So the model worked, but the challenge, I think, is that it's very resource intensive, right? You need one person supporting a smaller group of people, and it's very hard to scale that. In South Africa right now, there's a gap of 500,000 men who need access to, who have tested positive and need access to treatment. And so it's very hard to scale that model. And so in end of 2023, ChatGPT comes out, and our project is funded by the Gates Foundation. And what they did is, early 2024 said, can we quickly prototype and see, can generative AI meet this gap that our project is facing, right? Well, not really our project, but that the entire space is facing is, how can it augment the ability of those coaches to reach a greater number of users? And, working through a technology company, they're able to develop, and we supported the development of this model, deployed it via WhatsApp, because, in many parts of the world, WhatsApp is our primary tool of communication for those with smartphones. And the thing that we did was different is, and I think there's a common thread in health, right, is we need to be very sure that the health advice we are giving is accurate, quality assured, right? And so our knowledge base was built using treatment guidelines that come from the World Health Organization and from the Department of Health, similar to the Ministry of Health in South Africa, as well as coaching resources from our program. What we used to train the coaches was also used to help the model with especially things like empathy, right? And what we learned and what we saw is that I think the clinical pieces of it, the parts that are related to health information, that works very well. We tested this and saw that people liked the privacy in that you can ask certain questions that you wouldn't want to ask a health provider, you wouldn't want to ask your friend. So the anonymity was really positive. And on the clinical sides of it, on the medical part of it, it was really great at providing information at different points. And I think one thing that is difficult to do is, how do you address the psychosocial parts of it here, right? The mental pieces of it. And so we took the lessons from this prototype from last year, and we're now in the process of moving into the next iteration of what the works looks like. And what we are doing is, seeing if we can develop, test, and ultimately scale this chatbot that will do the things we talked about, right? How do you improve clinical outcomes? Meaning, how do you keep men and women now in care long enough that their viral load, the level of virus goes down, but also that you're affecting their psychosocial well-being. And for the clinical support, I think, that part, the LLM does really well, because you're providing information, right? It's questions related to what is the what medication, what does this medication do, right? And there are very clear guidelines that it can reference to provide you the information you need. But I think the thing we are grappling with is really around the psychosocial support, right? How do you help somebody process a positive HIV diagnosis? How do you help address potential mental health issues that I'm feeling now that I've received this news? Do I need to disclose my status to my partner, to my family, to my friends, so they walk this journey with me? How do I do that? And how do I address stigma and discrimination that I am feeling, self-stigma, but also that I expect to receive from, the society that I live in? And I think that's where we are realizing that, there's a little bit more work that needs to happen before we can get to where we really are able to address these psychosocial issues that are the ones that are hindering men and women from accessing HIV care and treatment services. And so what we are working on is then recognizing that it needs more than just the AI model, right? And we need to work with other sources of support that men can receive. But first on the model, one of the things we learned from the previous prototype we developed is that it it provided responses that were very formal, right? Like a health provider speaking to you. It was very formal. And that's not what our users want. Why the coach model worked was that it was an informal conversation. And so what we're doing is developing personas that can then be relatable, can be trustworthy. But split them two ways. One would be a more formal one, a second one, a more informal one, just to ensure that we are meeting people's individual preferences. The second one, and I saw this as well from the previous presenter, was the model cannot tell you, it cannot truly have empathy, right? What do I mean by that is you can't tell it, I can't type in and say, hey, I'm really worried, I don't know what to do. It can't tell you, I was in your shoes, right? I have had this experience, because it actually isn't true. And so what we're doing is we have a series of videos that had been developed previously and are going to be testimonial videos, if we call them that, short videos that really tell the story of men who have walked this journey. And what we'll be doing is presenting those, give you the option to, hey, I hear what you're saying, you're worried about this particular thing. Here is a short clip of a man who has walked this journey. And so presenting truly that human interaction through a video vignette. And the third one really is just recognizing that there is a need for us to escalate at some points where a man may feel, okay, the AI chatbot has taken me as far as I want. I would like to reach out to somebody. And so having call center people on standby who you can reach out to and have an actual conversation, we think is going to be useful and very necessary. But I think in summary, we truly believe that what AI is doing and the potential that AI has is really support that behavior change process, right? By both providing the information that people need to make informed decisions, but also by addressing some of the psychological and social aspects that influence health behavior. And we think by doing that, we truly can improve health outcomes. Thank you.
Thank you very much. Thanks so much, Wycliffe, for quite an insightful talk. Yeah, it was really great. Do we have questions for Wycliffe? I wonder if, okay, I didn't check my teams. Okay, any questions for Wycliffe?
One quick questions about the multilingual. Yeah, I guess you probably answered it because when you were sharing the Vietnam work, not at this level, you were speaking a different language. So, but in a particular locality, like you in Kenya, if you deploy a solution, what plans do you have if you don't yet support multilingual interaction between, your system and the users?
Yeah. Yes, and I think in South Africa for the prototype, we did work with a multilingual solution for local languages, including Zulu and Xhosa. And it was using the Google Translate solution. And I think the challenge there as well, similar like in Kenya, is the language is very formal, right? And so in our first iteration, we'll just deploy it in English. What we're working is building out, and through our partners, our technology partner called Ordere, is building out a slang dictionary that of common words that you'll expect to find in a chat, right? So that it can understand what it's being asked and then can respond back. So there is some work around handling the slang bits of the language that's being done on the side.
Hi, thank you very much for the presentation. You have quite a bit of experience from the radio side to mixed media in terms of television, and to now this, what I call this chat interface form factor. What are, from your experience, were some of the biggest challenges kind of translating from these other different forms of mediums, whether it's radio, to this kind of chat interface, which at times also there's a certain sense it's limited in terms of the kind of things you can do. Have you had a chance to innovate around that side of like saying, maybe perhaps you don't need a chatbot, maybe perhaps a totally different form factor in which people can interact with that? Have you done any experimentation on that end, or are there any just general thoughts from your experience since the radio days, basically?
Yeah, I have some thoughts. And I think the biggest thing that you lose when you move, especially from audiovisual into chat, is the ability to detect tone and see emotion on faces. It's very difficult to see that, and so how do you begin to express it in a chatbot, right? And some of it is just in simple things like having the bot say ish, that's it's recognizing your emotion, and it's responding in a way that allows you to know that it feels you. Double-edged sword, and I think it's something that needs to be looked into. We've experimented as well, and there was a company we know of who are doing a video avatar, right? And we're using it in a research context of having the video avatar ask questions and you respond. We think that works as well, but there are limitations in this part of the world around the bandwidth, and what does that do to your internet? So there are challenges, but I think there are ways we can find to all of us solve this problem, right? Because it is early days, and is video the right solution? It might be, but bandwidth, data challenges.
Hello. Can I just ask one from chat, and then we just have 2 minutes and we'll move to the next session. So we have one from Victor. Victor is asking, does your use case include leveraging the model for any form of clinical workflow, like self-testing, and how did you measure accuracy of the process?
Okay, so our project is currently not looking at the testing workflow. We are working with a partner called Ordere, Audre, who actually have done a lot of work in the self-testing space, actually in South Africa as well. And what they are doing, and I just said this in Kenya as well with in the malaria space, is primarily having a computer vision model that reads the tests of a rapid test kit that you're doing at home, right? Sort of like a double check of what you're seeing. And so there is space for that. But we are not stepping into the clinical space to, because the clinical workflows are a lot more complex. What we're trying to do is get you into the clinic, and then the clinic can take care of you from there.
Thank you. I'm Basi Mokaria, and I'm just curious. The solution has been deployed via WhatsApp, right? what are some of data privacy measures that have been put in place? For instance, if a user's WhatsApp account has been hacked. And then the second one is the solution addresses potential mental health issues, right? So can it be able to detect, diagnose, say, signs of depression based on the user's input? Yes.
Okay, and just a quick correction. We are about to deploy it, so it's not live yet. But what are the data privacy issues? One of the things we've grappled with that a lot, right? Because it's tied to your personal phone. And there's a simple solution, which is really, you can lock that chat with a chatbot, right? And that's something we'll be telling people that you can do. The second one is the way it's set up is it has the potential to flag, it can flag potential harmful behavior, right? And so, for example, if there is threats of violence, if there is threats of self-harm, it can flag it and pop that out to I mentioned a care coordinator who can reach out. We're still trying to figure out, and a lot of this we want to test with users. We think it would work, but we want to test with them because there's a line between, how much can you share of the conversation I'm having with an individual, with the chatbot, because we first want to make sure there's privacy, but we also have to balance that against the need for, potentially mitigating against harm. But you've just begun to scratch the surface on what the ethical issues are. We are dealing with them. We actually have an advisory board that's helping us walk through some of the challenges we anticipate we'll face, not just from an ethical perspective, but also managing the legal, regulatory, societal norm issues.
Appreciate Waitley. Thank you very much, Waitley, for your insightful presentation. Yeah, let's dive deep into our today's theme. So at this point, we will have, the panel discussion session. If you're joining us online, please just stay hanging there because we are about to, dive deep into our today's theme, how AI can, drive impactful innovation here in Africa. So as we arrange the chairs, we're going to take like 2-3 minutes to do that. And maybe we can grab juice for those of us who are here. We can just grab some juice and stretch.
Yeah, definitely stretch. And there's drinks at the back for everyone. Thank you.
And as they are doing that, because they are those of us who are joining us online, I'll just read bios of our panelists. So one, we have Dr. Skylar Fixman from IBM Research. So Dr. Skylar is a senior research scientist and manager at IBM Research Africa. Over the last decade, he's worked on AI applications in financial inclusion, maternal and child health, and fairness in machine learning. He earned his PhD and master's from Carnegie Mellon University and now lives here in Nairobi, our first panelist. Number two, we have Dr. Stephen Obonyo. So Dr. Steve is an AI researcher specializing in machine learning and bioinformatics. His work has addressed complex problems in drug discovery, RNA sequence design, and generative modeling with a focus on low-resource languages like Swahili. He holds a PhD in computer science from Paris 8 and has also served as a lecturer and machine learning engineer. Thank you very much, Dr. Steve, for joining us. Next, we have Dr. Jude. Dr. Jude Mwenda is the co-founder and CTO of FastTagger, a deep tech startup focused on democratizing AI through edge infrastructure for low resource settings. He holds a PhD from Georgia Tech and has conducted research at institutions like MIT Media Lab and Harvard. His work blends deep technical expertise with a strong grounding in the social sciences. So Dr. Jude will be joining us very shortly, but that is Dr. Jude. Next, we have Dr. William Ogallo from Google. Dr. William is a senior research scientist at Google, focused on AI and machine learning for global health and food security. He has led impactful research and strengthening health systems with expertise in health informatics, data mining, and predictive modeling. He holds a PhD in biomedical informatics from Columbia University and Bachelor's of Pharmacy from the University of Nairobi. And last but not least, we have Dr. Ignatius Eziani. He is from Lancaster University, but also our visiting researcher here at Microsoft Research Africa. Dr. Ignatius is a researcher at Lancaster University focused on bridging the gap between academic research and African languages technologies. His work supports the development of NLP tools that are inclusive and contextually grounded for underrepresented languages under the continent. So guys, let's clap for our panelists. And it's going to be moderated by Dr. Gimao Abebe, who leads the Microsoft the Microsoft AI for Good Lab here at Microsoft. Yeah, one more time. Yeah.
Yeah, thanks, Millicent. Thanks, everyone. Really excited for this panel discussion with panelists include current colleagues, former colleagues, friends. Really excited for it. We have roughly 45 minutes. I have a hard stop at 5 in case I need to go, Jackie, or maybe Jules will handle the last minutes. I have a meeting. But again, thanks for joining the invite and making your time here. So Millicent, we have the other mic, right? So that we could share with the panelists. The first thing first, let's just make it light. I would love to discuss on 3 main topic areas: AI in general, and a bit more specific on generative AI models and its equitable outreach. And then finally, sort of advice and recommendations from the different works we have been engaged ourselves on. But the first question would be to start with each of you, what's your favorite AI model is so far and why? Other than you developed it.
This is going to be a generic answer. It is ChatGPT because it's the one I have the easiest access to on my phone. And my kids will want a bedtime story, and we give it the basic ideas of characters, usually from Minecraft. And it then generates something that they can help kind of read through as well. And so I think it's probably my reasoning of why it's my favorite is that experience, not any technical capacity of the model, but just an example of a way we use that on a somewhat regular basis. That's why it's my favorite.
Cool. Stefan?
Okay, so for my case, I think my favorite would be we have these LLMs or AI applications which are in the medical space. I first technically interacted with them during my studies some years back. And what really moved me was how we can be able to actually have these systems solve real world problems. Like right now, we're talking about proteins, which is all about diseases.
Yeah.
And if you look at back then, it would take 5 years, one PhD student just to be able to understand the protein folding, but now we could do that within a few seconds. I think that was really, really my favorite, the protein models and the bio-based models.
Understandable. You coming from Jacaranda Health, that makes sense. William?
Yeah, so because of my work, I'll just say Gemini. And most notably, recently is the Notebook LM.
which is pretty like a very cool solution where you could bring in your PDFs, your videos, any text, any URLs, and then put them in context, and then it will give you a way to analyze that context, including how to converse with the people in a podcast, which is pretty like innovative in a way, from a user experience point of view, not just from an LLM point of view. So I like that angle that they took for Gemini and Notebook LM.
Thanks, Jude.
Hi. My favorite is Sonnet by Cloud from Anthropic. Simply because of when I'm sitting in front of the computer writing code most of the time, that's what I use. But because I'm at a Microsoft event, yes, I still pay for GitHub, and I have the GitHub Copilot in there in the back end. But most of the time, I've found myself using the Cloud, because normally gives me better answers and more refined. Yes.
Thanks.
Yeah, it's a difficult question. I won't say I have a favorite, to be honest, because across GitHub, Collab, and of course Azure Access that we have here and then at the university where I work, I have access to different models. So in general, I use OpenAI's GPT set of models a lot because I have access to them in my work. When I'm on Collab kind of platform, obviously that doesn't apply. Gemini sets in and something like that. So it really depends on what I'm working on. I don't have a favorite, but occasionally I can task all of them to do one thing for me and see who performs best. Yeah.
Thanks, Ignatius. I have a few questions. So given the panelist is coming from a mix of academia, research, startups, and also big techs, I tried to make them specific to some of you, but in case you have a few points to add, please feel free to jump in. My first question goes to Skylar, actually. We think more than 10 years now, you have been working on trustworthy AI before LLMs come in. How do we ensure with William as well, we build AI solutions that are actually people use? And I just want to zoom out a bit before Gen AI specifics, and if you share what does trustworthy AI mean and the kind of process development in you and our former organization you have been in place so that solutions are trustworthy, inclusive, and equitable.
That question wasn't one of the pre-provided questions. So yes, Girmal is correct. We have been working on this space of trustworthy AI before AI was as we know it as now with LLMs. And IBM still supports and develops these things we call toolkits. And it started off with adversarial robustness toolkits. This was the idea where you could change a picture a little bit and throw off a model. And so we developed these toolkits, which are a combination of different methodologies, and then open source them on GitHub and hand them off. I led a lot of the work for IBM's AI Fairness 360, we're trying to be cool, toolkit. And this was, again, bringing together lots of different methodologies around the idea of fairness and most commonly predictive AI models. So, classify a 0 or 1. Is your model making systematic errors? How do you test that model? It's different than the original training process is. And so, again, for a long time before LLMs took to the scene, IBM was creating these toolkits and then open sourcing them and usually giving them to the Linux Foundation. And I think that was a really nice way of compiling models together, linking them with some sort of kind of common syntax like sklearn, kind of common syntax, and then pushing it out to GitHub. So it has been an area of interest for research and for industry on how accurate your models are, not as a measure of AUC, but as a measure of are your mistakes impacting different subsets of the population in ways you wouldn't want. And so that continues to be important with LLMs, arguably more so. But the idea of trustworthiness in governments existed way before generative AI. And I think it's really cool to build on those types of experiences, even though generative AI is becoming a beast of its own. But the generative AI did not create the trustworthy questions. Yes. Yeah.
Thanks, Sky. And there are, I think, robustness toolkits and others anyone could use and play around to check.
Yes, there's explainability toolkits. There's a steering toolkit that's planned. I don't think steering is out yet. Robustness was one of the early ones, and then fairness is probably the most popular one.
Yeah, that's from IBM research. Jude, I want to come to you as at first tagger with limited relatively resource compared to others. How do you see those trustworthiness, inclusiveness, and sort of questions as you develop solutions for different problems?
Yes, totally. We are a edge company, edge AI infrastructure company. And because you're a startup, we are dealing with different parameters in terms of compute, clients. Do the clients have the capabilities to kind of deal with the regulatory aspects? And so for us, it's been mostly just focusing on building the infrastructure, but then helping the clients. We are kind of outsourcing the problem to them, but also helping them through that process.
Yeah.
And so part of it is also using the NIST AI framework that was just released in 2023. But at least we do have some toolkits kind of help them shepherd through that process. So that's explainability. That's why we kind of spent quite a bit of work. But of course, also because you're having low resources, you have to pick your battles, pick and choose. We do have evaluation frameworks also, but also that's based on the different clients we have. So we basically have this standard framework. Of course, there are certain kind of parameters we look at, like fundamentally whether minimal data collection, that's one of those kind of things we normally insist upon. And then also the other thing is basically offline inferencing. So this market is very price sensitive. Even big companies that normally have huge compute, they see the bill from ChatGPT and they run away. And so that's where we are good at. We kind of are able to tell you, hey, you can try this small model. You can get you an edge server and reduce the compute for you. You can also kind of get it within your own infrastructure if you want it, and then we manage it for you. So we're kind of removing also that headache for trustworthiness. But of course, I think there's still a huge deal of work to happen in terms of cloud computing and also basically, because the problem is that, yes, you have inferencing, but what happens if 10 million people decide to come and want that same inferencing? And so, so basically for us, it's kind of one of these, a startup is you're always fighting fires each and every day. And so you're basically dealing with the conditions that are right ahead of you. But we do use like the NIST framework as a guiding principle about what to do and what not to do. But also, of course, if you're having a mature organization that has quite a bit of a good IT department, that really, really helps. Yeah.
Great. Ignatius, you have a very good opportunity to see things from, Lancaster University now with Microsoft Research as a visiting researcher. But I know you have been also involved in Masakane and grassroots communities. So having this perspective, what's your take on the necessary steps to build that equitable AI solutions with a focus in Africa?
Yeah, thank you very much, Jamal, for that question. Yeah, when I got into this space, one thing that became clear quite quickly is that the success is being recorded by the big tech companies on what they were doing and based on what's happening in the global south. So a very simple example is Google Translate. The number of languages it was supported like 10 years ago, you could guess. And even when they report the successes they've recorded, if you are a speaker of that language, you find out that that's not really working. So I got in to see how do we, especially for African languages, how do we have techniques and methods that will get them to leverage language technologies as they are already existing. So you think of assistive technologies, for instance, if somebody is speaking a particular language, but there's some sort of, say, a blind person who's an African is speaking a language that's not English, but the tool is already there. just not in the language that they want? How do they leverage that without necessarily reinventing the way when they don't have the data, the skills, the resources to be able to create there? So we began to build these communities. One, data was a problem before Gen AI and large LLMs. So these communities helped, like Masakana you mentioned, they helped to basically bring people together and nurture them into understanding what's actually going on. So because there was also a skill set deficit among these people. So even if for some reason you have everything ready to run, who does it? Who does that? So mentoring became an issue, but we all came together. We had Masakane. Luckily, most of the people who participated then were also in school, so they engaged with their institutions. So before you know it, we grew a very large ecosystem of people who are working in this field. So a lot of African languages then had data to start with. We had playbooks like Notebook, a Google Notebook set up to do simple things like find 2D models to do translation and things like that. But over time, large language models came, so widen the gap again. So you can no longer do it at that scale. So the next question is, how do you now distill these models or adapt techniques that will help you get efficient and performance systems, even when you're not playing at the level of really large parameter models, if you see what I mean. So, but the fact that we've built an ecosystem of people who are working, who also agreed to join these big tech companies, join universities, expanded their tentacles and also reach out to become mentors in other places. It helped. So everybody's thinking about this, and you've seen the presentations here. For instance, without wasting a lot of time, I want to zoom in a little bit into a question that was asked about Farmer Chat, which is one of the projects that I'm working on, about the problem of language. So we know that Whisper supports Swahili, for instance. When we run that into the system, we're using to basically evaluate the performance of, say, the ASL model. What we found is that the ASL for Whisper does not perform because they collected our partners, Jacki and team from Digital Green, gave us, correct me if I'm wrong, gave us the Kenyan Swahili, right? Whisper is mostly based on Tanzanian Swahili, as I learned today, right? And it's not performing very well. But the interesting thing is that in spite of that, when you try to retrieve, it somehow generalizes well enough to retrieve the video that you wanted to retrieve, but it does not do translation. So there are all sorts of problems going on. How do we leverage that? That's the kind of thing that the collaboration we are mentioning between the universities and groups like Masakane, Lelapa, Data Science Africa, Black in AI, all these other groups coming together to have people who are contributing to the same effort. Thank you.
Thanks, Ignatius. You mentioned on collaboration and how it's important to build and scale our efforts. You mentioned communities in the continent, but also I think William has also mentioned earlier the need to collaborate with domain knowledge experts. We tend to have similar focus areas lately on geospatial, agriculture, and the related problems. And I think even Jacki mentioned in her remark, the ML part is getting easier and easier. What's still a challenge, like how you can collaborate different efforts and to build a solution that actually work for everyone remains to be a challenge. And I just wanna get your insight on the need of effective collaborations. Even if you are big tech, that by itself doesn't mean a lot if you really want to build a solution for a local problem.
That's a very good question, Gilmore. And I think it's one of the most important pillars of achieving success when you're coming to build these tools. Remember from historically as humans, based on Steve Jobs saying, we are tool builders, but without context, without knowing about things like the theory of change, we can't get to the right solutions, right? So I think partnerships, whether with small companies or
startups compared to big companies and academia and industry experts, ethical experts, or governments, and so on and so forth are very critical in different ways to ensure the success of these solutions that we are building. I think to just give an example is to provide domain expertise. For example, the people who build AI tools are not necessarily the people who are familiar with the problems and the context. And so in healthcare, in agriculture, in any other field, it's very, very important to partner with the people who care more and know about the context and the knowledge about the problem. So I work in food security, for example, and being fortunate to work for a big company, we have a big client called the World Food Program, which provides for us the context about the problem, the data that we need to solve the problem as well, and also basically a way to evaluate the solutions at scale, right? And also beyond just the data and the idea of domain expertise, I think there's also an element of this partnership bring about the notion of equity and fairness in terms of like who owns what, or who owns the data, what are the ethical practices about like, providing the right solutions for AI, from AI, and how can this be sort of like governed in a different way that can make sure that they're risk-free when they're being used. They are based on the scientific method when they're being created, and also they can scale equitably across, all different kinds of ecosystems.
Thanks, William. Yes, I think the collaboration, even beyond the data, sometimes in my own line of work, even understanding the problem takes effort, right? You mentioned food security, but it could mean different for different people. Some focus on the soil, some focus on the yield, some on the climate. So that coming together really helps us to even clearly define the problem, understand the infrastructure, and potentially build a solution. It may not be that big model at the end of the day, but at least once you know the context, you can build the solution that may fit for the purpose. I would like to get Stefan's perspective on collaboration, because we know Jacaranda were such an effective entity in collaborating with different organizations. Google mentioned maybe other organizations as well. Can you share us like what are the collaborative efforts at Jacaranda House and lessons learned in building equitable solutions through such collaborations with other entities?
Okay, great. So we at Jacaranda we have several different types of collaborators. So we have technical partners we are collaborating with. I think you've mentioned some.
Yeah.
And our technical partners have played a key role because we're training like large language models, and these are very expensive to train. So we've had free credits to be able to train our models, of course. And on top of that, we also have collaboration with the government, especially the county governments, because when we're right now we are in 23 counties out of the 47 where we are currently operating from. And the manner in which we operate, we want to be able to go to the hospitals at the county level and be able to register moms to be able to use our platform so that they could ask questions about the pregnancy and the health of their babies and so on and so forth. So when the mothers are being signed up, usually the coordination could be very hard because at some point we need to tell these mothers that we need their consent first of all before they start using our system, and we have to take them through. So coordinating this can be very hard if we don't have partners such as the county government. So apart from that, we also have other partners as well, which are also just trying to help us streamline our operations and deploy our models so that it can be used by anyone in Kenya. Because if you look at our platform, you find that a mom can just send a message to ask if they can be eat avocado while they're pregnant. And we could be able to respond that through SMS-based platform. So I think when it comes to the equity part, which I think if I got that well, right, the equity part?
Yes.
So for the case of the equity, so I think if you look at how we collect our data, So how we train our AI models is such that, first of all, we have questions which mothers ask. Then we have help desk team, human beings who are actually answering those questions. That's what we feed into our AI model. So it means that our model, when you train it on Swahili data, it knows the informal Swahili, how people text, especially the mothers here in Kenya. So what that means is that we are able to reach a wider population, and we can be able to adapt to these low-level Swahili nuances. And on top of that, since we are serving on top of SMS, it means that we can be able to, anyone who even has a smartphone, or if they don't have internet connection, they should be able to use our platform.
Thanks, Stefan. Just on that, let me try to transit into the next point, which is generative AI. Jacaranda House with its Uliza Lama is one of actually the good Swahili-focused models in town. And that was released in 2023, if I'm right. So what has the progress so far? What are the wins, in scaling your advisory to mothers using this new model? What are the things we learned, at least in the last 1 or 2 years since it's released?
Okay, so a good question. So at the moment, daily we are answering 12,000 questions from the mom. And on the platform, we have 3 million, more than 3 million mothers we are serving. So we are also, what this has done is that instead of the help desk team handling all this traffic of questions, we can be able to automate some of them so that this LLM can be able to automatically answer the questions.
Yeah.
But on top of that, we have a check whereby if the question is very critical, we can be able to escalate it to human being to actually call or answer that and even follow up with a call.
Yeah.
So on top of that, what we have so far is we are scaling up. We are planning to roll out in Tanzania. We are also planning to roll out in Ghana, Nigeria, and other parts of Southern African countries.
Thanks, Stefan. That's scaling to 12,000 questions, you said, daily.
Yes, daily 12,000 questions.
That's only possible because of, I think, the opportunities offered by generative AI.
Yes, exactly.
I want to come back to Judah, actually, as a fast tagger. Given the resources you have, what are the opportunities this technology offers, Gen AI, and then potentially any risk you may see on that regard? Maybe then Sky could add up on the risk Gen AI could have.
Generally, I think in terms of opportunity, I think from the clients we serve, I think there are two things we normally help them with, which is accuracy in terms of their workflows and time, So we have a financial document model, which is being used by a certain company, and their kind of decision making was just taking a lot of time. And so kind of having that model and having a bunch of questions from that document and then being able to ask those questions. This was a typical analytical work that they will have to sit in there and basically look at the rows in the table and so on and so forth. So that also was a Microsoft product, which was Table Transformer. So we kind of added that, then also fine-tuned the model to kind of do that for that, then added a bunch of other documents in there to help it do that. The biggest risks in terms of Gen AI in the workplace, or I just fundamentally, I think, and this basically from the social sciences. I don't want to go into a rant, but anyway, I think fundamentally when you think about the work of Xerox PARC and building the word processor and the graphical user interface, there's fundamentally something about Gen AI and how we have to use it in the workplace now, And there's something about a certain piece that was written by the reflective practitioner, Daniel Schoen, about how we work, how we gain experience, that whatever you did in grad school is normally useless, but what you get in experience the day-to-day is normally very, very important. And so I kind of see this also with some of kind of my interns, whereby you kind of get hallucinations, but you don't know exactly what is going on. But if you have quite a bit of experience, you will be able to know, yeah, this is wrong. Can you just go and correct it? But the biggest risk maybe I'm afraid of, but not so afraid of, is just fundamentally that idea that what do you think about practicing and being like a practitioner? There's certain things you just have to do on a day-to-day basis, like a carpenter, before you become an expert, so that when you use this Gen AI tool, you can be able to see when it's doing the wrong things. Yeah. So I think that's the biggest risk. Of course, also part of it is the history of technology has its stories. If you go and look at The clock in itself, you know how the clock was used as a way to measure time. The fact that now people go into an office, then COVID came, then we forgot about the office. So there are certain dynamics that kind of occur, and I kind of feel as Gen AI is just part of that in the office environment. And those agents are just part of that continuation, but there'll be some shifts that are going on. So my biggest risk is just like expertise in itself.
Perfect. Thanks, Jude. Sky, any quick comment on the potential risks on Gen AI?
I do want to get to the risks. You had a question, and I think it was with William, talking about the importance of understanding the problem. And I just wanted to throw one little jab in there because we spent years understanding a problem, and we knew the problem well, but we tried to use technology to fix a problem that wasn't a technological problem. And I just wanted to emphasize that to the crowd here. There are lots of problems that you can very well understand. You can be boots on the ground here working with people experiencing that problem. But it might not be a technological solution that's really needed to impact change in that space. And we didn't want to see that in so many of our different projects we started off in early days. So understanding the problem and drilling down further, whether or not technology is the important solution to push the needle farther. So that's one of my comments. The second one, echoing the comments already about this, generative AI is going to be a tool and a crutch. And I think generations will lean on it differently, on the tool, and whether or not it just becomes something that replaces day-to-day activities, which sounds great. But if that becomes the start and end of that workflow, so many things will get lost in this. And so I think just this general balance, I don't think it's going to be a societal collapse because of generative AI, but this type of over-reliance on a crutch, I do think will have lots of downstream impacts for another 10 years to go. And yeah, that's not the doomsday, kill us all type of scenario. But there are some real concerns about large scale use of generative AI.
Yeah, that also includes disinformation and as challenges we may have. Let me come back to William actually, and then maybe Ignatius later. I think John presented a big building density and many others which are more of like global models. I think the question came for local contexts always, you may not need that big, large global model to get works done. And when you see more food security, geospatial type problems, even African language and related, what are the tech to include African contexts into those models? You said with WFP, which usually have like more global perspective in problems and related. How do you nail down those problems into local context? How do you often balance building that local model versus that global model you always produce and make the connection there?
Yeah, that's a very good question. So I think it still goes back to just knowing about the problem and the context. And I think one experience from myself and our team is that we began off with very local models before going to the bigger global models. And it took us like a year to just work with simple models, linear regression, elastic net models, to think about like, how does this look like when it represents forecasting of hunger, for example, in a given geolocation, right? A specific location, one location. And just by beginning that small and knowing all the data biases and model inaccuracies, the foundation of that, like what's persistence, for example, and what's a seasonal model, is what brings back the beginning of the journey to like a bigger global model. So to me, I think it's a matter of just spend time to know the data, know the problem, and know if, as Scala says, if a given technology can solve the problem. It doesn't have to be complex. We can, I think we're in the era of Gen AI and LLMs and all that, but there are some problems that can be solved by simple linear regression models. And we still need to think about what's the most effective way of doing this? And I think we spoke to it earlier that through John, when he said that even for the open buildings work, we are using now state-of-the-art models, but we began somewhere small. And if you're in a place where you don't have the compute, it doesn't mean you just go and do something else. You can still experiment with whatever you can do in CPUs, for example, right? And see if you can solve your problem. And then you incrementally improve on your model. So I really think that that element of knowing your problem, knowing your context, and then figuring out what's the simplest solution first before building a much more complex, much more nuanced, or much more global model would be really, really important moving on.
I cannot agree more in a way. That's exactly what even happened in one of our projects with Kenya Space Agency. In Muranga County, they want us to build land use land cover map. And there are different maps from Google, of course, European Space Agency, ESRI, and related. But those global maps out there, they are okay globally, but when you really evaluate them locally, it doesn't work. But a simple data, satellite imagery, and smaller model actually work much better than those global models. So that's just a testament in that regard. Something I often hear more frequently in AI conversation in Africa is data and context, of course. I have this dilemma. Are we still looking for more data from African languages to be incorporated for the development? Or should we have, the context we have, which is low data regime, should that be, a force for us to think differently and build differently rather than following the traditional way of scaling data and model? A global summit happened in Kigali a couple of weeks ago. The conversation is more often data missing in Africa. So I want to take actually Ignacio's touch on this, even Jacki, if you have more perspective. Are we still collecting more data, or should we try to change our narrative and process so that let's build a solution with our local context, which is low data regime in the first place?
Okay, thank you. That's a very interesting question. Let me start, touch on what's already been said by my colleagues here, that that's a huge challenge to take LLMs line, hook, and sinker. Satya recently said that the advent of Gen AI simultaneously lowered the barrier and also increased the height. So you can get in quickly, that's all right. But the challenges it throws for even those who are already there are massive. Data for African, language or related works. From where I stand, we have to be realistic. We will never be able to get the amount of data that's required to train the kind of models we have. But neural networks in general, especially transformer models, require data. So the more you can collect, the better. The issue is that we will never lose track of evaluation, even after deployment. This is what's been done in software development. And it is going to be, the evaluation is going to be multifaceted. I mean, some of my colleagues touched on that. It's not on the metrics that you can easily basically implement as part of your training process, but also what is socially, culturally acceptable. So we'll have to keep developing evaluation protocols that include both, the core metrics, and then of course how these things play when you deploy them in the field. And when you deploy them in the field, in fact, I read somewhere yesterday, someone was basically making an analysis on LLMs, and the way he put it, he said that LLMs are very confident liars, right? They are very confident liars. So all of us have this tendency to believe first if you do not scrutinize. So on top of whatever we build, we do not trust it. And we can always generate very nice examples for presentations or even for publications, but that's not the experience users are having in the field. So we can collect more data, but not any data. We can apply other techniques, including what we're looking at in our team around synthetic generation of data, to make sure that our models are performing as expected based on a very wide array of metrics and rubrics, both in practical sense and also in the society. So we have to continue to do that. But we'll never expect that we'll build as much data as English has on the internet. That's not going to happen, in my view.
Sure. Jacki, you want to add one or two?
Yeah, I also have to go for 5. We're good. Won't talk for 5 minutes. Yeah, I mean, we can. Like, you're absolutely right. What we should be looking at, and we also can't build the technologies for every single situation. Like, the only people who can do that are the communities. I highlighted just a few communities, but if you look at the accessibility community, that's not a single community. You have visually impaired people, you have dwarfism, you have all sorts of different things. And then a group in Kenya on I think there's a short stature group, one of the groups that the team's collaborating with, and a group in the US might have completely different ways they want to be represented. They might have completely different ways they want to use these models. So what we have to arrive at is something smaller. So something smaller, much lower cost to run. And I'm hopeful for the lower cost because if you might remember, computers filled a room and now they're in your pocket. So we will get there. But they have to be smaller, much lower cost to run and customizable by communities. And that's going to be really hard to get there. And one of the hardest things will be making them transparent enough that as you adjust, for example, if your community bringing your data set, which you want to keep owning, and you add it to your model, which you're training, you need to understand the consequences of that and be able to see the consequences of that. So maybe you're adding the wrong type of data, or maybe you're improving one feature and another feature is getting worse. And so, I mean, this is a massive user question. But it's not, again, just like I said, you don't want ML people on their own building these models. You also don't want HCI people on their own. It's like we are going to have to work closer than we've ever worked before if we're going to and come up with new methods and new ways of understanding each other's and building and iterating. So cool. Yeah. Sorry, I almost took 5 minutes.
Yes, I think thanks, Jacki.
So sorry.
We are wrapping up. I would love to have more questions for the panelists, but we are on top of the hour. I really thank everyone. I think this is very unique in our African setting, different organizations sitting, discussing, what we can do together, how it should be done the right way in Africa is actually a good thing to take. And we hope to have more conversations going forward. But I really want to thank you all, the attendees, but also the panelists. Thank you very much.
Thank you.
Thank you very much, everybody. Thanks for a wonderful panel. It was so insightful, educative, and yeah, Gimao, thank you very much for moderating it, and yeah, good job. Yeah, thanks everybody. Yeah. Yeah, I think we've come to the tail of it, and at this point, we'll just have a quick closing remarks from Dr. Samuel Miner, and then we can just.
All right, thank you so much, everyone, for making time and taking time to come and learn with us. So the theme was AI for Africa Future, Innovation, Equity, and Impact. And it's come out quite clearly from even the discussions we've had from the questions that the challenges that we face are diverse, the tools are diverse, but also the beauty is the skill set that we need is also diverse and it's available. And it's one of the things that we are so thankful as MSR and AI for Good Lab, that we have friends, partners, research community around us that we've worked with from diverse companies, diverse expertise that we can all work together. There's somebody who said that if we want to get further, we have to go together. Because clearly I like the phrase University of Nairobi, okay, the flip of it that talks about the fountain of knowledge. And clearly there's no organization, no individual is a fountain of knowledge. And it's all about all of us from IBM, Google, Microsoft, Amazon, even our colleagues from Jacaranda Health and Fastaga. Yeah, Fastaga, yeah. All of us, coming together to discuss our learnings, our experiences, and being able to share that. And my hope and my goal is that this is a conversation starters, that all of us, we continue talking. We continue interacting with each other. I remember a while back, there was a conversation even around having a joint seminar for some organizations. And I know the people from IBM and Google who are actually spearheading that conversation, and Gilmore has disappeared. He was supposed actually to ensure that from Microsoft, we are well represented, because we need to do this. And there was also a bigger goal. And I remember Aisha, your lead at Google, she was like, we need to bring ICLR or a major conference to Kenya, just like it's been happening in Rwanda, or it happened in Rwanda and also in Ethiopia. And I think this would happen when we all come together as researchers and figure out how do we pull our weight, how do we push together and put together a proposal that can be adopted. And so from our side of things, we just want to say thank you so much to all our guests, Jacki, who started us off with a conversation about equitable AI, John, about mapping, and other interesting problems that you've been working on. Jacqueline, our partners from Digital Green, who've also been with us in the journey when we're looking at how do we bring technology in agriculture. Wycliffe, we've worked together, we've done some stuff together. I think even last year we had a workshop here, conference, seminar in health in December here. And even from the panelists, different expertise, different experiences, both from big tech, fintech, not fintech really, startups, health institutions, health organizations, and even from all of us being able to bring together our different experiences and our different learnings, because it's all about learning from each other, our experiences. How do we bring this together? I don't have to repeat a mistake that you went through when you're doing your GIS work, right? I don't need to. I just need to talk to you and I'm like, okay, these are the loopholes. These are the challenges you faced. And from the paper you recommended, I just read there and, be able to jump us. And that's the whole essence of even sharing all this in academic community. And so from a side of things, from Microsoft Research and AI for Good, we want to say thank you so much for coming in today. And even for the team that is online, we appreciate you. Thanks for taking time from your busy schedules to really be with us and to learn from one another and to be able to, even the questions that you've asked, I'm assuming this conversation was recorded, right? Yes, it's being recorded, and I know it will be shared for future reference and future discussion. So for our side of things, thank you so much, everyone.